how does geological carbon storage work in the Arctic? Imagine a world where we can capture carbon dioxide and store it deep underground, helping to combat climate change. In the Arctic, geological carbon storage is a key part of this vision. It involves capturing carbon dioxide and placing it in underground rock formations to keep it from entering the atmosphere. This process is vital for reducing greenhouse gases and is particularly relevant in the Arctic due to its unique geological features. The Arctic is home to vast amounts of organic carbon stored in frozen soils, known as permafrost, and beneath ice sheets. These areas have accumulated carbon over thousands of years, creating natural reservoirs. For instance, sediments under the Greenland ice sheet contain fossil organic matter preserved by ice. In places like Siberia and Alaska, permafrost holds significant amounts of organic carbon buried deep in the frozen ground. This natural storage capacity is essential for long-term carbon containment. To store carbon dioxide, we first capture it from sources like power plants. Once captured, the carbon dioxide is compressed and injected into deep geological formations. These formations can be depleted oil and gas fields or saline aquifers. The impermeable cap rocks above these formations trap the gas, preventing it from migrating back to the surface. The Arctic sedimentary basins and subglacial sediments are ideal for this purpose due to their depth and stability. Permafrost plays a dual role in this process. It can act as a natural seal, helping to contain the injected carbon dioxide. However, with rising temperatures, thawing permafrost poses risks. If permafrost thaws, it may destabilize carbon stores and releases greenhouse gases. Therefore, any geological carbon storage initiatives in the Arctic must carefully consider these environmental changes. In addition to geological methods, the Arctic also benefits from biological processes that sequester carbon. In marine environments, phytoplankton capture carbon dioxide and transfer it to the seafloor, where it gets buried in sediments. This natural carbon burial complements geological storage efforts by removing carbon from the atmosphere. Geological carbon storage aligns with sustainable resource management goals in the Arctic. It offers a way to reduce atmospheric carbon dioxide while utilizing existing geological features. This approach can be integrated with resource extraction industries, such as oil and gas, by repurposing depleted reservoirs for carbon dioxide storage. This not only supports economic activity, but also addresses climate impacts in the polar regions. In summary, geological carbon storage in the Arctic works by injecting captured carbon dioxide into deep underground rock formations. The region's extensive frozen soils, sedimentary basins, and ice-covered sediments serve as natural carbon reservoirs. This method helps manage the Arctic's carbon cycle and contributes to global climate mitigation efforts. However, the success of these initiatives depends on careful site selection, monitoring, and consideration of the changing Arctic environment.